Hello everybody, it's Deanspillabean back on your screen, and today I'll be talking about how to create an after image program within Veadotube. I've recently started this project trying to make this Roaring Knight avatar here, and I've been trying to make this whole after image tech work for a while, and I finally actually got to a point where I feel comfortable showing off how I got the entire thing to work. So this video is kind of going over my thought process making the entire system in general. This is only a small part because how this works and how I'm going to be explaining it is that actually everything is split into 10 different projects, all of which basically have everything that you see here running simultaneously. And I've been able to figure out how to get them working separately yet synced up correctly. And I hope to go over that in this video, as well as just kind of show off how this all works so that any of you all can also make these after image programs in the future. So starting up, we're actually going to need two different project files, one for a dynamic avatar and a second one for a scene. And you really don't need to name these things anything specific. It's just anything that works for you is completely fine. I'm just going to name them frame test, scene, and one for the project file too. So the end goal of this is we should have about 11 different project files. That's basically the frame test file that we made as well. And make sure that we have about 11 different versions of them. One will be what I'm going to be calling the leader sprites, and the others are going to be basically the secondary ones. And I'll also be naming all of these to follow suit. We're going to be naming one of them F0 and the others just F1 through 10. And I'll just rough all of the project files into position. I'm definitely going to be adding some more stuff later. It's just when we start out, this is probably what you'll probably need the scene to look like when we get to that part. For now, we're going to be going to the project file, so you can just close this out and save it somewhere else and get back to it later while we work on the project file. So starting off, I actually like using what I'm going to call the origin point for a lot of models that I work on. This tiny dot here is actually what's going to be modified throughout the entire project. And I'll show an example of what we'll be doing with all of the sprites going forward. We've got this sprite here. We'll make sure that the image mode is set to pixel. That way it has like a very clear image. And at the moment, the origin point, I'm going to put it here on the top layer just so we can see it. And we'll be modifying the night image here. We can actually position it on the left tray here. That way we can like position it around where we want it. Maybe like right there. It doesn't have to be perfect. It's just as long as we got it where we want. Next, we'll be clicking this little dynamic button here, which what that does is pull down a drop-down menu that allows us to use a attach feature here, which use that, and then we can tell it layer origin point. So it'll attach to the layer point here. We go back and disable the rotation, skew, and scale, mostly because we don't really need any of those other position points. Whatever modifications we do to the center point here will be made to any other sprite that's attached to it. So to show off what I mean, we'll go to origin point, new dynamic effect, move. It'll spawn a move node here. We then get a point construct. This will apply different point values so we can actually like have some positional data. And just for this, we'll be using a generator wave function. We'll put that into the Y, which we could put like other stuff into the X if we want, but just for this demonstration, I'm just using the Y value. Already you'll notice that it's moving a little bit, not enough, so we'll have to get a multiplier node from the math tree and plug that all in. Get a number value, and then we can multiply that by a number of our choosing. For this, I'll be using 17. Or maybe just 10 for now. I'll also be going to the wave node here, and we can change the velocity. I'm going to change it to 4 here, so now it goes up and down a little bit quicker. We could probably do a bunch of adjustments if we want, but for the demonstration, this is just what we'll be left with. And something else that I do in some of the avatars that I work on, I try to get also a cursor modifier here so that if I want to, I can actually move it with my mouse. So we're going to get that set up too. For that, we'll need to go to compare, convert, branch on Boolean, and then put a branch here and have a toggle ready so that whenever I toggle it on, it'll swap between using the wave function and the cursor. And we can toggle it on by using a signal input. And for this example, I'm just using the key Z. I'll be putting that in. Plug that into the branch, and I technically have control over it, but I'm going to need to multiply it a bit. I do like to have the X and Y values on different multipliers because that way you can actually get like a rectangular field that you can work with. So for the X value, we'll be going for a 400 multiplier, and for the Y, a 200, which will effectively kind of fill the screen that you're working on. Get a point construct in so that we can turn it back into point data that the program can use, and then plug that into the branch. So now, if I got this all set up here, it should swap between cursor whenever I press the Z button. So now it actually does swap between them, and it goes back. Of course, swapping between these is like really jarring and instant. So to fix that, we can actually go to timing smooth and then put a smooth function in between the two. Doing that, now that whenever we swap between them, it actually smoothly goes from the mouse position and back to the original position that it's at with the wave function. So this is just the beginning that we'll work on. This way we can also move the avatar around and get a good grasp of the functionality of the project. Next thing we're going to be doing is construct what I'm going to call the clock. Just demonstrating a later version of what it'll all look like. The idea is we have a clock go on in a loop that we can modify with different values, and then that dictates how fast a separate clock moves to basically give us a number between 1 and 0, which will end up smoothly transitioning between those two numbers, and basically allows us to get up some other modifiers so that we can use them for other parts of the project. We're not there yet. I'm just giving you a heads up of what this clock is used for. Now, the clock itself has actually undergone a number of different tests in order to get it to work, because an issue that we have is that the clock itself should be modifiable, or at least like with the project that I'm doing. So to show what I'm talking about, I have a counter here that is connected to a variable. I can set it to 0.4 as an example, and okay, for some reason it doesn't want to update. I don't know why, but I have to like reconnect it. I think that's just a bug with the system, but basically that allows it to actually start ticking faster. Why do we want it to tick faster? Because the stuff that we'll be modifying down here actually needs to be adjusted around what the clock speed is. And later on in the project, I'll be having like different modes that it swaps between. I have two different modes here. One that have different values for how long the images should be on screen. So, while working on this, it basically ended up being imperative that I get one that was as accurate as possible. I started with a repeater function. All of these different clocks here are using repeaters. They basically try to count in different intervals to get to their number. Now, in all of these, it basically has one more than its max value, because basically it checks as soon as it reaches the very number that we have listed here. It then basically resets itself, which is pretty good whenever you want to have a clock constantly reset itself, but it's not good whenever you want to know exactly when the clock ends. So that ended up being an issue because it tended to skip the final number, so you would never really know when exactly it reaches that amount. I can also speed up the time here to, I'm just going to say 200. And you can see down here booleans that should be updating every time that it reaches the maximum value. And very clearly, they're not getting updated at the same rate. This is simply because the last number in all of these is usually getting skipped because of how fast it ticks up. So I ended up making this other part over here in order to test out a clamp counter instead, which will actually fix my issue in that it does the last number and would actually like output the last number, and then it could actually check the output here. If I actually speed this up to 500 times as an example, you can already see these two are very different, where this one's not updated as much as the clamp function, and this one's using a repeater. So this was going to be good for a while until I figured out some other method in order to get it more accurately updating. And this is actually going back to a repeat function, but instead of waiting to check for the max value, I actually use a value change node here and have a counter that goes in one-step intervals between 0 and 2. And the counter tries to basically count up from 1 and then goes up to 2. However, as soon as the program detects that it has reached 2, because it's a repeat function, it automatically restarts at its base value of 0. So this effectively allows you to have a counter that goes from 0 to 1 at a constant rate, because as soon as it hits the number 2, it instantly resets itself. But the problem is that there's no way to detect when it reached that 2 unless you use a on-value change, because on-value change can actually detect things fast enough for the values to be changing. So it's not actually detecting for the number 2, it's detecting for when it changes from 0 to 1 and back and forth. Which, actually, and you can see here that the little green bar at the top indicates how accurate this is. Technically, it updates much more often than the clamp function, because if you use a clamp function instead, there's a small chance that whenever it reaches its max value, that it doesn't tell everything else that it's at its max value yet, which can actually cause the output to be inconsistent enough that you get this little bit of variability here. So using a clamp that swaps between 0 and 1 and checking the value change there actually becomes much more accurate. I spent weeks figuring this out, and I'm just really happy that I was able to get it to work. I made this entire testbed setup to show this off more. It basically ended up with a fluctuation amounts that centered around 1, which actually measured to about a 1/1000th error rate or something like that. There's still a couple issues that I need to kind of fix with it, but good golly, the accuracy is really good now, and I'm happy for it. Okay, I'm gonna stop gushing about how the clocks work, because I swear it actually took me a while to figure out the clock things, and I just want to talk about it. Okay, so how to set it up? We're going to timing counter. We'll be using a repeat. Set the repeat to 1 step, minimum 0, max 2. So now it swaps between 0 and 1, and whenever it detects a 2, it restarts immediately. We're going to have a second counter here that it doesn't have a range mode. It goes up in 0.001 second intervals. And now we'll pull out a compare convert on value change. Whenever the counter value changes, it'll update the other counter down here. So now it can go between 0 and 1 and resets on the second. And this is our clock. Straightforward and simple. Next, we'll be working on the fade functionality, where we'll go into the main sprite itself, add a new dynamic, go to the fade option, which will bring in a fade modifier down here, have that available. And normally, if we plug it into this counter over here, we'll just plug that in. You can see that it starts like starting from 0 going to 1. It'll basically go into different opacity modes, which obviously for the after images, this is not going to work exactly as we want. So we'll have to pull up a math expression. I love using expressions because I can actually tell it what math I want without having to use too many nodes. And we'll say it starts at 1 and then subtracts a being the first connected value, which pretty much all that does is literally invert it. So now it actually goes from a starting fade and go down. But we can go a little bit further here and actually make it start off at, we'll say 70%. So now whenever we start off with the project, it actually starts at 70% and then scales all the way down to 0. Next, I want to actually bring up object in and out. These two nodes practically make this whole project work. So if you don't know what these two nodes do, basically you can tell it to have a different input. I'll just have frame mode, and it can be used as where is it? As a number value. I'll also do the same for object out, frame mode out. Use that as a number. So now I'll just add in a add function. This will allow you to basically have a number go into the project itself and also have a way for a number to go out of the project. Which, if we actually go back to our scene really quick, you can see that all of these got updated with new nodes. So now, if I pull up a value of 0 and then a add function just to show it off, it'll what goes in as a 0 comes out as a 1. I can also change that around, and you can see that it updates live. So with this, we can actually check for if or what mode that we should put the program in based on if it is a 0 or something greater than 0. So in this case, we have a not equal to function. We have a if 0 is equal to 0 and it is not, it outputs false. Then we can put that in with some of the other program stuff in here I'll get to later to basically be used for mode 0. Like, for example, if we want the fade function to work or not. So for that to be checked, we need to get a branch on Boolean here. We have it linked to the check if it is 0 or not, and if it is not 0, then it will output the fade function here. So we can actually see the night fading out, but that is because it's on mode 1. We can set it to mode 0, and it'll change here. We can even check that in the scene here, and I'm going to increase the scaling and move it around a bit so that we get in the very center. Change the scene setup just to make it darker, just so we can see it in a nice background. I'm also going to disable all of the after images so that we only have just the main one here. So now, if we set the mode to 0, you can see that the fading doesn't happen, but if we set it to 1, then it does happen. This is effectively how the modes work. So we'll be leaving that one as 1 or 0, sorry. And then the rest of them will be set to 1. And because of how we actually got this plugged in, we can actually daisy chain them together. The output of one goes into the input of the other. So now all of these different images are on their own, basically on the different mode than the primary one, because we've set the others to mode 1 and the primary to mode 0. The next part of the project is to actually get the movement of the sprite working for the different after images. So at the moment, actually detach it really quick, it moves like completely still, but ideally whenever we get the after images set up, it will record what position that our night is at the time, and then apply a small movement modifier that causes it to glide slowly behind itself and then reset whenever the clock resets. So for this, we'll be leaving the mode to 1 so we can work on that. And we're actually going to need the positional data coming out of here, so that way we can also get any mouse movement that we have as well. In order to store the current position of our night here, we're going to need to use what's called a state storage box. This is pretty much the only way that you can store information into the program without some weird wizardry that not even I'm aware of. So next thing we'll need to do is convert the point information into a string information. And to do that, we can actually go to string and then go down to string from point. Connect the output from the branch into here. So now we can actually get the actual coordinates into a string that's stored. However, this information's coming in too quick, and we're going to have to limit that. To do that, we'll need to get a compare convert, branch on Boolean, and then have it so connected to the point value on true. We then go to our clock over here and then connect that output into the Boolean here, which what that does is actually limit how fast the information can be processed into the state storage, effectively limiting what kind of coordinates we get access to at the time. After that, we actually convert it back to a point. So this way, we actually have a point value that has a very specific y value that only gets updated periodically based on whenever the clock is actually finished running. Next, we'll actually get the x and y value out of the new point value that we got. We'll notice that the x value is a 0. Ideally, we're going to be adding a couple numbers to that. Next, we'll be pulling up a expression and giving it the equation a plus parentheses b times c, where a is the x value from the start, b is going to be the value that we want it to go towards, as in like the x coordinate that we wanted to be towards, and c is actually going to be the counter up here that gets reset at by the counter from earlier. So this ends up making a number that scales from 0 to 40 and resets based on the clock counter, which if I get a variable for the clock and then set it to, I'll say 2 times, so now it operates twice as fast, it actually speeds up the time it takes between going from 0 to 40. This also updates the updating time here so that it gets the height that it requires into the storage. And after all of this, we can actually get another construct here and reassemble this into new point values. We'll then go back to our move function, have a new branch on Boolean, disconnect this, connect those two together, have this one false normally, and then bypass the new 0 to 40 value that we had earlier into the branch, and the Boolean turns on if the value is not 0. Now, I've actually ended up placing this in the wrong orientation because I had the smooth function there. For this to work better, I need the smooth function to be before the branch. So the end result of this is we actually have a after image that fades from 100% opacity to 0. Actually, it's more like starts at 70% and scales down. Or actually, it doesn't do that quite. Oh, yeah, that's right. I think I remember I needed to do some specific maths in order to get the counter to be updated at the same rate, correct? Or, no, shoot, was it as simple as I just plug that in? Oh, okay, it is that simple. And make sure to, when you get the value of how fast you want the clock to move, you also update the counter down here with the same speed. So now in this demonstration, I'll be hiding the origin point so you won't be able to see that. But if we save and go into our test area here, you can see that the after image is actually being made. But you might also notice that all of the after images are stacked on top of each other, and we won't be able to actually see everything correctly. That is what we're going to be fixing next. So the next thing we'll need to do is go back to the object input and create a new node. We'll be calling it the reset node. Usage Boolean. This will be a signal that we are going to send into the project itself in order to manually reset the clock for each and every instance of the project. Just to show an example, I'll be pulling up a button here that allows me to just test this out. Press the button. That ends up resetting the counter here. I can actually move it down here so you can see a bit better. Click. Stops the counter. And you might also notice that this counter goes up continuously. And also, I just now looked up my reference. Basically, in order to make sure that the counter down here doesn't get set off in a weird way, we'll actually have it connected to an OR output. So now, or an OR function, now if we press the button and have it held down, the counter reaches 0. Once we release it, everything starts working properly again. Something else, we'll also go to the output here, create a new node, and say counter out usage number, And we'll actually connect the output of the counter here to that, which will result in basically the same number that comes out of the counter going into here. So now, if we go back into the scene, just with a simple change like that, we can have access to new Boolean inputs. And for this, we're going to need to expand out a bit, so give me a moment. We'll then need a button here as well. And just for now, I'm also going to put in a input signal, just as an alternate way to trigger this. And I'll have this set for the X key. Attach that to a Boolean OR. And then next, we'll be getting a Boolean latch and have one of these each connected to each of the project files. And then also get a timing delay. Have that connected to each latch as well in the middle Boolean for true part. And then also for each of these delays, they're going to be off by about 0.1 seconds. So the first delay will be 0.1, the next delay will be 0.2, next one is 0.3, next one is 0.4, so on and so forth. We'll then connect to the output of the X or button area into each of the delays. And then finally, a compare check that goes to each of the latches Boolean for false input. Each of them will be comparing the previous project and checking what the output is and compare if it is greater than 0.1 seconds. So again, for each project, we have a output data here that outputs the clock signal. So we're actually checking for whenever the clock reaches 0.1 seconds, that's what will trigger the latch to reset. So when we have it all done, if we press the button, it'll reset all of the Boolean delays at the same rate. So by the end, it should look something like this, where again, all the delays are on a 0.0 second interval. Next one's 0.2, next one's 0.3, 0.4, 0.5, so on and so forth. Then what that does is enable a latch that, why doesn't that want to work? Oh, yeah, I need to disable the primary one, don't I? Okay, it doesn't look quite right. I'll iron out the kinks later. First one that we're going to iron out is what keeping the after images staying on screen. That's not supposed to be there. To fix that, we'll actually go back into the main property here. The problem is, we'll take our button next to the fade modifier. If I press it, we can see that the fade modifier actually stays at 0.7, as in its like maximum value. So we'll need to change that. This is actually kind of an easy fix. We'll just have a separate branch on Boolean here. Check a couple things. The check that we'll be having is if the counter... Let's see, compare counter to value. If value is 0, if true, trigger branch on Boolean false, which will set the fade value to 0. So now, whenever I hold down the button, the counter reaches 0, the value checks if it is equal to 0, it then checks itself, and when you know, the output is 0, so it changes the fade value to 0, which ends up hiding the actual image itself. And once I release it, the images come back. And we can actually see that get fixed in the main project here. There we go. Now for another issue. Oh, why is that happening where it's actually kind of desynced a bit? Let's see, looking at my notes. Oh, so the branch out actually goes to smooth and then goes in and reverts into the... Oh, okay. Okay, so it doesn't actually come out. Here it goes out over there instead. Is that what I ended up doing to get this to work? I'm also trying to figure out what I did in order to make this project work in the first place. Oh, yay. Oh, there we go. Nice. All right, so there we go. We actually got one mode done, the trailing mode, in order to get the after images set up, and already we're done with that. Ain't that cool? So that was all of the information that I could tell you about how to actually create your own version of the after image code that I'm working on. The rest of the video is actually going to be talking about a bunch of the additions that I've done to the base foundation of the code that I talked about earlier. First example being actually changing between the different sprites, which ended up being a bit more complicated than you might think. So I basically have a very simple setup. I have 3 different sprites that we swap between. Each of them have a different string associated to them and a different check where a keyboard bind checks for F19, this button, F20, or F18. These are just the keys that I have bound to my mouse that I use for a lot of my projects. All of those outputs then go into the state storage that checks the states. And over on the side, I have a couple different states. We have standby that just works on this version. Stand guard, that's this one. And aura, that's this one. It then does a check after the state storage what it's all equal to, which all this does is the standby and aura sprites, when they are equal to those, goes into this branch down here that basically makes the mode set to 1. And then there's the stand guard sprite, which when detected sends it as a 2. What this does is allow me to choose between mode 1 or mode 2. Which, as you might guess, allows me to have different modes be set to specific sprites. And then the current mode of that sprite is outputted into the object out. That way I can daisy chain all of the other project files and basically say what exact mode that I'm on without constantly updating those. I also have 3 nodes over here. The top one is for the button delay that I talked about earlier, where I actually have a button here in the middle. If I press that, this is the clock over here as well. If I go over and press the button, you can see how all of the clocks reset every time I boop, boop. Press the button, the clock gets reset. The second variable in the very middle basically dictates what mode everything is in. Right now in the project file, this doesn't actually do anything, but whenever I'm in the scene, whenever I have any of the different strings connected, it basically outputs what mode everything is at. So then that's what actually tells all the project files to work. And then the last variable down here is actually what frame specifically everything's at. In the project that I have at the moment, I don't actually use this yet. I have some future plans that kind of takes advantage of what frame of information everything is at, but at the moment it's not used. So over here is what I have as the advanced version of the clock that I made in the demo process earlier, where it actually takes a value from, if I scroll over here, which different mode that I'm on. At the moment I'm on mode 0, but I can actually go to this variable here, change that to 1, which will set the project's mode variable to 1 here, which then gets transferred over to these different modes and says, hey, no, it doesn't get shown there. It goes, oh yeah, it goes down to here, which has a different branch on string, and basically says, hey, whichever mode that we're on is what outputs are connected. So in this case, since I have it set to mode 1, it outputs the second variable, which here, let's see. So this node checks it. If it is 0, it outputs 1. If it's a 1, it actually outputs the information from mode 1. Same thing for if it's mode 2, it actually gets the information from mode 2 instead. Pretty much the positional data as well as the scaling from top to bottom, or from 0 to 1 or 1 to 0. Basically the same thing. Only thing I did differently was actually combine them into one big string here, just so I can have like one pipeline go into everything, so I don't have to have like 2 of everything as an example. That information then goes to the different modes, and you can see it being split off once more into a number that goes from 1 to 0 or 0 to 1. Pretty much does the same modifiers down here, except turns everything into a string, which then gets checked down here for which string values need to go, and then we follow the trail one more time. The clock information goes to the giant clock, and then positional information goes to the positional modifier. Pretty much everything here is kind of about the same. It's just either more condensed or reorientated. And then finally, over on the far side, we have fading connections to all of the different sprites in order to change what the fading effects of all the sprites. That is purely connected to the clock over here. So the 1 to 0 value that comes out of the clock goes directly into this relay that affects the fade value of all of the different sprites. And this box is a lot bigger at the moment. That's because any new sprites that I want to add in the future will need to have their fading effects into that specific box. And then one more check that I have here is pretty much the same thing that I had before, where one of the or the images themselves would stay at a visible rating, and pretty much what this all does is the same thing as I did before, changes it to a 0, so that whenever it equals 1, it doesn't. It equals 0 now, so it's invisible. Now, a couple quirks that comes with dealing with multiple sprites in this. You might be able to check here in the state storage how I'm swapping between them pretty quickly, but the sprite up top actually doesn't change instantly. That is because I actually have a little check down here that if the mode is not equal to 0, as in this case it's equal to 1, so the gate is open, it basically bypasses how the information from the state storage actually gets to the current state, or the current state mod right here, basically preventing it from going through to the current state unless the connection goes to this relay, which is routed from basically the output of the clock. So whenever a clock cycle ends, that is to say, whenever the image itself reaches the end of its cycle, that is when it updates. And the last check down here is actually updating the positional data. I found that the clock needs to be updated as soon as possible, but the positional data needs to get changed eventually, or over time. Basically, it uses the same check as we did with the sprite change, or the state changer, where it checks whenever the clock ticks, and only then actually tells the program what mode to swap between. Because if we don't have this, all of the all the after image sprites change simultaneously when we really want them to have different sprite links, since we're going for different modes here. I can actually demonstrate this by bypassing and basically updating the mode as soon as possible. Where if I then go into the scene file here, reset everything so that they're all working correctly. If I swap between different modes here, you can see that the after images just change very suddenly. Whereas if I go back in and basically detach this so that it only updates whenever the clock is finished, that now causes the after images to actually update at the end of their cycle. Now, at the moment, there's still like a couple issues with how I have it set up where like there's this one dark sprite there that I still need to figure out exactly why there's a dark sprite. I don't know for sure, but everything else kind of works. I think I'm going to end the video there. So, thank you all very much for watching this insane rambling of me just trying to tell you all how to work a after image into your project. Probably won't be able to like retroactively add this in. You kind of need to make this as your foundation pretty much. Regardless, that's going to be the end of the video. Thank you all very much for watching. I hope you enjoyed that, at least some amount, and you all have a good night. Bye.